Before you start marking, make sure you have a green pen to add any additional information to your answer and a blue pen to annotate your answer. The first question. Draw one line from each solution to the pH value of the solution. So the first one I've done for you, acids have a pH lower than 7, so it can't be 7, so it must be 5. Neutral substances have a pH of exactly 7. You should have all got 2 marks for that. The ion that causes acidity when in the aqueous solution is H+. When sulfuric acid is added to sodium hydroxide, a reaction occurs to produce 2 products. So you should know that when you add an acid and a base, remember a base could be a metal oxide, a metal hydroxide or a metal carbonate. When you add either a metal oxide or a metal hydroxide to an acid, you produce a salt plus water, which is what we see here, the salt. So it's sodium from the base, sulfate from the acid, and water. How many elements are there in the formula H2SO4? So they mean elements and not the number of individual atoms. So there's hydrogen, that's the first element, sulfur, the second element, oxygen, the third element. The answer is 3. What is this type of reaction? So the acid and the base are, one is the acid, it's acidic, the base is alkali, and then when you react those two, you produce 2 neutral substances, the salt plus water, so it's a form of neutralization. The salt produced, so we have the sodium from the base and the sulfate from the sulfuric acid. Doesn't matter if you spelt that with a F or a PH. Describe how an indicator can be used to show when all of the sodium hydroxide has reacted with sulfuric acid. First thing, add indicator to the sodium hydroxide, then gradually add sulfuric acid, and when the indicator turns the solution green, you know all of the sodium hydroxide has reacted with sulfuric acid. You could have done this the other way round, so add indicator to sulfuric acid, gradually add sodium hydroxide, but this point remains the same. You did not need to specify what colour the indicator would have changed to have got that 3rd mark. So you could have just said, when the indicator turns colour, you know the reaction is complete. So give yourself a mark out of 9 there. Okay, complete the diagram to show all of the arrangement of the outer shell electrons of the hydrogen and chlorine atoms in hydrogen chloride. So hydrogen has got just 1 electron, so 1 electron, and that's its outermost electron shell. And chlorine has 2, 8, 7 electrons, 17 in total, and 7 in its outer electron shell. So we're only concerned with these outer electron shells. Now when we are drawing a covalent bond, which is what it is because both of these substances are non-metals, and when non-metals bond, they form covalent molecules. And what you need to remember when you're drawing a covalent bond is for every 1 electron shared by 1 atom, it needs to receive the same number of electrons back. So hydrogen, it needs to gain 1 electron to make it 2, so it needs to share 1 electron. It's going to share its 1 electron in that overlap, and it will need to receive 1 electron back from the chlorine for it to be equal. And we'll draw the chlorines as dots so that we can see this one must be from hydrogen, this one from chlorine. So we've drawn 1 of chlorine's 7 outer shell electrons, we've got 6 left. Now we always pair the electrons up when drawing covalent bonding, so we'll pair them, the 6 electrons up into 3 pairs, so 1, 2, 3, 4, 5, 6 at equal distances apart from each other. And that's the covalent bonding. Okay, hydrochloric acid is a strong acid, ethanoic acid is a weak acid. Describe a reaction that could be used to show the difference between a weak acid and a strong acid. You should explain why the weak acid and strong acid give different results. So the first thing, measure out the same volume of hydrochloric acid and ethanoic acid. And then I've made it really clear, you need to place them in separate beakers. Now you could have said measure out 50 centimetres cubed or 50 millilitres. The idea that we're using the same volume, you could get a mark for that. You could have got a mark for saying measure it out with a measuring cylinder. Add the same mass of metal to each beaker, and you could get a mark for saying measure using balance. Or you could have said measure 20 grams as opposed to same mass. Use a stop clock to time each reaction. And then that's the description of the reaction. The explanation next. So as strong acids, and you could have written from pH 0 to 3, such as hydrochloric acid ionise completely in aqueous solution, it is expected that they will react faster than a weak acid. And you could write pH 4 to 6. Now the reason why we would expect a strong acid to react faster than a weak acid is because a strong acid has more ions available because it ionises completely that will be able to react, whereas with the weak acid it only partially ionises and it takes a while for it to ionise, which means that the reaction is slowed down whilst ionisation is taking place. And the reason so, they will react faster than the weak acid, which only partially ionises in aqueous solution. A strong acid contains more H+ ions than a weak acid of the same concentration. So this is really important. So both of them have got the same concentration, so let's say 0.5 moles per decimetre cubed. But the strong acid has more hydrogen ions than the weak acid of the same concentration, and that's why the strong acid is pH 0 to 3, whereas the weak acid is pH 4 to 6. And I would say it's quite difficult to mark these 6-mark questions, but the mark scheme says, let me find the mark with you, to be in level 3 there needs to be a detailed and coherent explanation of comparative results between concentration and ionisation. So you must have said that even if a strong and weak acid are the same concentration, because the strong acid contains more H+ ions, it will react quicker. You must have made the link between the amount of H+ ions and concentration. You could have said, even though they are the same concentration, the strong acid ionises completely, whereas the weak acid ionises partially. That would get you into level 3. If you haven't said that, you can only be in level 2, which is maximum 4 marks. Copper oxide reacts with hydrochloric acid to produce copper chloride and water. So this is base acid changes into salt plus water. So that's an example of a neutralisation reaction again. And then it says copper oxide is gradually added to the hydrochloric acid until in excess. So we start off with a, let's say, a pH above 7 because it's a base, and then it's added to the hydrochloric acid, I would say pH 0 to 3 until in excess. So we start with this, the hydrochloric acid. Sketch a graph on figure 1 to show how the pH of the hydrochloric acid would change. We start with hydrochloric acid, so I'm going to say pH 1.5. And then, so we start here, oh, that's 0.5, 1.5. And then, as the copper oxide, which is the base, is added, the pH of the hydrochloric acid is going to raise. And that's until we get to pH Y11, and that means that the salt and water is produced and the products are neutral. So this is, I'm just going to annotate it for you so you understand. This is the pH 1.5 hydrochloric acid. This is gradually adding the copper oxide, and this is pH 7 when salt plus water produced. So this is when neutralization actually occurs. And we would see that with the universal indicator because the solution would turn green. Now the next question, magnesium reacts with hydrochloric acid to produce magnesium chloride and hydrogen. So metal plus acid changes into salt plus hydrogen, not neutralization. Plan an investigation to find out the accurate volume of hydrogen produced. So accurate means close to true value. And this is the setup of the practical that I'm going to describe, and I thought it would be easier to show to you. So we have the magnesium, strips of magnesium with the hydrochloric acid in a conical flask. There is a bung at the top of the conical flask, and there's a delivery tube fitted to the bung. What we have here is a measuring cylinder that we have initially been completely filled with water. It's been inverted, turned upside down, and the delivery tube will be passing the hydrogen gas produced up into the measuring cylinder, which will be displacing the water. So this is hydrogen gas, which displaced the original water in there. And you'll be able to tell how much hydrogen gas was produced by finding out the volume in this area of the measuring cylinder. So here is my explanation. I might refer to that image again to help you understand. Measure 10 grams of magnesium using a balance and placed in a conical flask. Now, with regards to that, you could have said just measure the magnesium. I would have accepted place magnesium in a conical flask, but if that's the case, you won't get into the level 3 because you're not thinking about trying to control the mass of magnesium. Fill a measuring cylinder with water and place upside down in a trough with water inside. So this is the measuring cylinder we would fill with water. This is the trough that we would also fill with water. Use a measuring cylinder to measure out 25 centimetres cubed of hydrochloric acid. So again, we're just showing that we are controlling the amount of hydrochloric acid. Add the hydrochloric acid to the conical flask. So in here we have the magnesium and the hydrochloric acid in the conical flask, and add the bung quickly so no hydrogen gas escapes. So it's a nice thing to mention, how to ensure that there is little room for error in your practical. Connect the bung to the delivery tube so the gas collects in upside down cylinder. Repeat at the same temperature, and this would be to enable you to find a mean result. If you repeat and find the mean, you're likely to get the result close to the true value. A student reacts different masses of copper oxide, so a base, with excess zinc. Okay, so this is displacement. So we've got CuO plus zinc changes into, we've got Cu plus, and it'll be zinc oxide, but they haven't mentioned this bit. You don't have to worry about that. Here, the zinc has displaced the copper from its compound with oxygen, so that zinc is now in the compound with oxygen. This is displacement, and it can occur because zinc is higher up than copper on the reactivity series, so it's more reactive than it. Here we've got a graph. I have used it to find the gradients. So once we find the gradients, we need to find the change in y and the change in x. Now you could have done it by finding coordinates, but I've done it just by drawing a triangle and measuring change in y and change in x. That's absolutely fine. However you decided to work that out, what you need to be sure of is that you change in y over change in x. 4 divided by 5 in my case, it's 0.8. And this tells me that there's 0.8 grams of copper for every gram of copper oxide. It's really important that we recognise that. So 0.8 grams of copper to every 1 gram of copper oxide. That will be useful for the next question. Determine the mass of copper that can be produced from 75 grams of copper oxide. Okay, so again, we know 0.8 grams of copper to every 1 gram of copper oxide. So it's saying 75 grams of copper oxide. Well, if we have 75 grams of copper oxide, we need to know how many grams we have of the copper. So first of all, we had to multiply by 75 to get from 1 to 75 grams, so we'll need to do the same to the copper. So 0.8 times by 65, not 65, 75 equals 60. So that tells us that if we have 75 grams of copper oxide, we have 60 grams of copper. Make sure that you have got additional annotations for everything that you didn't originally write. Make sure that you have bugged your answer even if you didn't beforehand, and look through those questions, because you're not just doing this to avoid a detention. You should be doing it so that if this exam question comes up in your actual paper or very similar, you can do well. This is all about you being able to achieve in your exams. It's not about you avoiding a detention for homework.